There you go.
It's interesting that doesn't say this meeting is being recorded anymore.
Yeah, there's no big sound. And I think you'll be able to share as is. Go ahead.
Okay. So one of the complaints we've had over the years is how do people test their contracts? And a lot of time most people have been doing it manually, where they write their contract code, go to the command line, or use JavaScript, load it up into Node.js, send actions to it, see if it behaves like they expect, and then retry over and over again. And each time you bring down the chain, if you made any changes to your tables, you'd have to wipe the chain and start over. Now, internally, for those of us working on Node.js, we didn't usually have that issue because we had a tester library for Node.js that allowed us to create tests which rapidly bring up new chains, install the contracts, set them up, run them through a predefined sequence of steps, all very, very deterministic timing, and then do one chain after another in rapid succession, doing exactly the test we want. The disadvantage to that system is it was all native code, which would have been fine with except fine by itself, except our libraries for the native side were completely different than the libraries we provide for contracts. So the way you access tables is very different. The way you do actions is different, submit transactions different, very different from what you do in a contract. So the idea behind CL Tester is you write both your contract and your tester using the same EOSIO lib. Both get compiled to WASM, and then the tester executable that we provide executes both. And it gives your tester that you write the ability to rapidly bring up and down chains, decide when to produce blocks, decide which transactions to produce in every block, be very deterministic and very repeatable. Plus, with the advantage of since it's using the same library, you have access to the same set of database methods that contracts do. So you can run a bunch of actions, then within your tester code, just open up a table object just like you would just within a contract, start reading from it and verifying its contents are what you expect.
Sounds good. All right, you got a walk through. You want to show us through of how to actually use it?
Yep. Let me see if I can get this set up right.
And this is compatible with starting with which version of EOS? EOSIO?
2.0.
Okay, great.
Let's see. Do you see my screen?
Yep.
Okay. So there's a repository, a demo repository. It's an EOS community. It's called Demo CL SDK. And I'm going to run through the example I put here. This shows you an example of how you would write a contract and a test case together so that they work and are testable together. Down at the bottom of the README is our installation instructions for both CL SDK, WASI SDK, which it uses to build with on Ubuntu 2004, which that's the only instructions we have so far. Sometime in the future, as we get more time, we hope to add more architectures to this. After you've installed it, and then it goes through how you actually build the contracts and the tests and running the tests. The repo includes with it a sample CMakes file, of course, the README, 2 files to form the contract, and then a file for the actual test bench.
So that work folder, you install the 2 things to at the bottom. That's just the 2 dependencies you need.
Right.
Okay.
Right. You have all the packages you need to install Ubuntu, and then you just have these 2 things. In addition to this repo, which is basically use this repo as an example when you're setting up your own contracts.
Okay, perfect.
So there's a little bit different here. We're not using the CDT to build. Instead, we ported the CDT library and rebased it to be based on Abios. This library builds with the WASI SDK, which the WASI SDK uses off-the-shelf Clang with no modifications, just modifications to the C and C++ runtime libraries so that they work well within a WASM environment. Other people have already done that work, so there's no reason that I see for us to continue doing that kind of work ourselves when we can just reuse what others in the wider C++ community have already done for us. The downside of this approach is, for now at least, we lose the ability to automatically generate ABIs. So if you do go with a system, we'll have to write ABIs by hand until we come up with a solution for that. So this is what a contract work looks like on the header file. So one of the things to notice about this header file is this single header file, which is declaring the contract, it was used to compile the contract and it's used to compile the tester. So all the definitions you put in here, including all the constants, are available to the tester, and also including the table definitions. So here's a struct that we're putting into a table. This definition is used by the contract to read and write to the table. It's used by the tester to read the table without going through an ABI. And this little helper function is available to both the contract and the tester. Both can call this helper function directly, and it'll just work. So as far as the actual contract, there's a couple different changes to what you see in the current CDT, is that there's none of the special USAO attributes, since we're using a standard compiler, and the standard compiler wouldn't understand those anyways. Instead, we're using macros, which set everything up in the way the standard compilers can understand. So you declare your actions here like normal. And then down here, you put them all into this macro, and then that creates a dispatcher automatically. And of course, on this file, here's the implementation of it. At this point, it looks just like CDT code, except for the lack of special attributes. One thing that is different is right here, I have a function with a member that's an auto. This is a new thing with C++20. We fully support C++20 now, and that can be convenient for certain situations you find yourself in. It's a lot more convenient than writing template code, which templates are just the old way of doing this.
So when you say lack of attributes, this is we're kind of mixing two. This is kind of an update on two things. One is the addition, that the new tester, but also the changes that WASI brings to what contracts look like.
Yes.
Okay.
Yeah. So up here, you would have had something that looked like things that like that. Those are no longer necessary. In fact, the compiler will warn you if you put them in, because it doesn't understand them.
All right, awesome.
Now for the test code is broken up into these individual test cases. On the command line, you can have a whole bunch of test cases, and you can either run the entire set or you can run specific subsets as you need, depending on what you're looking at the time. For example, if you have a large suite of them, if they happen to do a lot and take a long time to run, but you're debugging one of the ones near the end, you can just run that one near the end. But since it's C++, you can define a whole bunch of helper functions and classes before that point that those test cases can use. And so for here I have an example of setting up the token contract. Is the this demo contract implements the deposit and spend pattern. And so it needs a token contract to talk to. And so this sets up on a test chain, it does the process of setting up the token contract. So it creates the account for the token, and that includes setting active to, oh, that should have been code. That was a typo. To support that so that it functions correctly.
And Todd, before we scroll down much, all the macros and whatnot that we're using here for the test library, all that's coming in through the one tester.hpp header file?
Yes.
Okay, perfect.
So for this helper function, you tell it what chain to operate on it. It creates the account for the USIO token. It sets the code on it. And you just give it an account name and you point it at the WASM. And it has this prefix because we're providing the token WASM as part of the SDK itself, including its header file. And then we start doing the various actions. So we create 2 tokens. I mean, you call it EOS and other, and we issue them. And so we have a shortcut syntax for creating transactions. So T is the chain you're creating the transaction on. As tells you what authority to do it under. So create a transaction with an action that's using USIO tokens authority. Act runs an action and verifies that the action is successful. If the action asserts or anything like that, then the test is marked as a failure and it gives you the error message from trying to do that action. So this is the action to do. It's actually pulling this from the header file. So I included the token header above. So it's defining these actions. And down here, this macro is both creating the system, creating the dispatcher for those actions, but it's also creating a set of action wrappers. And this, is one of the action wrappers that it created. So this uses the action wrapper to get the name of the action. It also uses it to get the parameter set so that it knows what all the types are and does the proper type conversions.
And S to A, is that a new helper function with
Yeah.
this library?
Yeah, that's a new helper function that comes with the testing library, string to asset. It's just a shortcut for constructing an asset.
Cool.
And so the next stage, where since we want to test attacks against our contract, we're also creating an account called hacker token, which is also running the same WASM, but it's under a hacker's control. So normally, when you do an action, embedded in this action wrapper is a default account that the code runs on. So the default account for this is EOSIO token. Here, we're going to be issuing actions on hacker token instead. And so that's what with code does. With code overrides that default. So instead of sending the create action to EOSIO token, it sends the create action to hacker token. And then it's using also hacker token's authority.
All right, so this is verifying that using the same contract running on a different account doesn't, like, basically the require auths are correct in the token contract.
Now, so this isn't, the purpose of this is not to test the token contract. The purpose of this is to use the token contracts, 2 copies of it, to test the contract, the sample contract, which is called deposit spent. So it's setting up 2 token contracts to make sure that deposit spend doesn't get confused. Something that was a common attack vector against early contracts that people in the community wrote in the early days. To verify that it didn't fall for that attack.
Okay, cool.
So when this function is returned, then the chain has the 2 token contracts and the two token types set up on the USIO token one, and then just the fake EOS token on hacker token. So now we have this other helper function, which creates and funds a set of 4 users. So for each of the users, it creates the account. It transfers from EOSIO, which was the issuer of the token, these 2 tokens, and then from hacker token, the fake EOS. So each user now has 3 tokens in their possession. And that happens for all 4 of the users once this function executes.
Okay.
Now the setup for our demo contract is a lot simpler. We just create the code account and set the code, and that's it. It doesn't have any setup actions on it. More complicated contracts like token will have additional setup actions you have to add to get it operational.
And it looks like there isn't a nesting. Is there a test suite idea or just individual test cases?
Individual test cases. Now there is a syntax for labeling. So you could do so if you marked a whole bunch of individual test cases with, say, a suite 1, you could tell it run suite 1 and it'd grab all the ones marked as suite 1.
And what is, oh, okay. We took a moment to update there. All right, so that's a way to group test cases.
Yeah. Completely optional. If you have a lot of test cases, you probably want to take advantage of that.
Right. What does it look, if you're going to get to this, don't mean to rush you, but what does it look like to run the test cases and specify that label?
So when you run it, do a so by default, it'll run the entire suite. There's a command line option. I think it was use that option. So had I defined a tag called my tag and put it on 1 or more tests, then that would have run just that suite of tests.
Okay.
So default is run all, or you can use the T option to limit it to specific tags.
Okay, cool. There's for some reason a massive delay between you typing and it showing up in the screen share, but but it does get there. All right, cool. It's pretty straightforward. And the name of the WASM is just the name of the test file with WASM extension?
Yep.
Okay. And CL tester does the compilation, or is there a separate compilation step before you run the tester?
The separate compilation. So CMake does the build process, and the README tells you how to use CMake to build it.
Okay.
And then for this example, it creates 2 WASMs. There's the there they are down here. So there's the contract WASM, deposit and spend, and then there's test, deposit, and spend.
Okay. All right, good. Anything else you wanted to demo today?
Yep. So for each test cases, so in this one I gave the example of 2. So here's the first and second one down here. You just declare instantiate a test chain, and then that does the entire startup process of creating the chain, creating a Genesis block, and then pausing that chain at the appropriate spot right at the beginning. At this point, it's just like you would create a fresh chain in Node.js where the only account on it is EOSIO. And what's
Is there anything worth saying here, Todd, about the kind of more on that topic? I know when we were testing ship and replaying ship logs and whatnot, like there was certain utility in launching the chain this way because you have more of the real life situation started from scratch. You want to talk about what's possible there that has been hard in the past?
So one of the things that this does, we're not showing this yet, but this initial release doesn't have ship support. We are working on a release that will have ship support. Tongue twister. With the ship integration, well, even without the ship integration, you control when it advances to the next block. In fact, you can even tell it to skip several blocks or even skip a year's worth of blocks so that you control time that the contract sees. With the ship integration, you also control at what point it sends an update to the ship consumer. So you might want to run through several blocks, then send the update all at once to make sure it can handle it, and then maybe do one block at a time, and then maybe do 100 blocks, then send the entire set of 100 blocks over the ship channel at once. It gives you a lot of control over that when you have the ship integration.
Okay, awesome.
When you're not integrating ship, when you're just doing contract tests, the control over time is mainly benefit, so you can test all the cases if you have contracts that deal with time, you can test that the contract responds to time correctly by controlling time.
Cool. All right, good.
So
anything else?
Yep. So instead of just repeating as everywhere, like this code up here does, you can just shove it inside a variable. That's what that does.
Oh.
The previous examples, the test fails if any of those actions fail, as we want those actions to succeed. Sometimes we need a test that the contract handles an error, detects an error, and issues the correct error message. So whereas act verifies that a transaction succeeds, trace does no verification, but this function instead returns a trace. Once you have that trace, you have this expect function, which you can use the expect to verify that that trace failed with a particular error message. So here we have Alice trying to transfer a token type other that the contract rejects, and the contract rejects with this message. So if the transfer succeeded, the test would fail because we say the test should fail. If it fails, but with the wrong error message, then the test also fails. Either case, it'll tell you that the test failed. And if it's with a different error message, it'll tell you the error message it failed with and the error message it was expecting.
Okay, cool.
So another aspect I want to get to, this is just a shortcut, but so this is the get balance function exists directly in this header. Now it's not calling into the contract, it's calling into code that's compiled into the tester. And that tester opens a table, gets a record, and returns it. And it's using that to verify balances after certain actions within the test contracts table. And here I gave an example that's a lot more explicit, where within the tester itself, we instantiated the table just like we were writing the contract code. We read it, and then we check the result. Now this doesn't have time limit limitations, unlike contract code. So you could actually scan a table with tens or hundreds of thousands of records, and it'll take whatever time it needs without timing out. And then you can run whatever checks you want on those records.
Okay, awesome.
And of course, since it's in C++, you can write tests in loops. So in this case, it's looping through 4 users, issuing them, transferring tokens into the contract, and then each of them is buying a dog, and it's verifying that each user does in fact get a dog.
Cool. All right. Looks great, Todd.
Now, one of the things that's interesting about this is, so each test case can spin up a chain, but that's not a limit. In this case, I have a single test case with 2 blocks of code. Each blocks of code spins up a separate chain. Within a test case, you can spin up in rapid succession, spin up, run some things, and tear down hundreds of chains in a small amount of time. And the advantage of that is often when you're setting up a test case, it's now in a state that's not ideal for the next test case. So you just tear down the chain, bring a new chain up, put it in the state you want to do the test you need.
Yeah, it's nice to do with the scope operator in C++. Cool.
And then when you're doing that, that's when it's definitely helpful to have these functions to set up the chain for you once you've instantiated it.
All right, beautiful. All right, anything else?
Nope, that's it.
Is there anything in the header file, other utility functions that are in there that we might want to walk people through, like the S to A?
There are a lot.
Okay.
So if you jump to the header file, it's loaded with definitions. Some of them are general purpose, like this executes an arbitrary shell command. So you can copy, rename files, spawn off other processes in your tests. Also, it's unlike contract code, a tester code can actually read and write files using C++'s built-in file operations. So here's the S2A shortcut. Most of the interesting stuff happens are members of the test chain. So there's actually a way where you can take a test chain and then shut it down, get the path from it, and then you can safely copy the box log out or copy its state file out so that you can take that and spawn it up in Node.js. So you can actually use a test environment to create a repeatable way to create test chains that you launch in more live environments to maybe test your JavaScript code. It also has a way of opening up. You can instantiate a test case, give it a path to a snapshot file that came from Node.js. Then it'll load that snapshot in. And then you can start modifying it, like replacing producer keys, replacing account keys, and other things. So you can take a live chain, replace a bunch of keys on it so that you have control over now this fork chain, and then use that as a basis to run some of your tests. And then if you really wanted to, you can then save off the state file.
What's walk me through, I don't know if I fully follow, walk me through the use case for the swapping keys use case.
So let's say you wanted to take a production network like EOS, and you wanted to run some tests that required you to have control over the EOS IO count and the producer accounts.
Okay.
This gives you the ability to fork the chain and do that.
And you'd have to have, okay, so you would have to have your own node caught up to do that, but you could then
Actually don't. So for like the EOS blockchain, there's some websites out there run by block producers and other members of the community where you can go in and download a snapshot to boot up your own node instance. That same snapshot can go into tester.
Oh, cool.
Now, personally, I haven't tried it with snapshots that big. So I hope it works with the larger snapshots, but I'm not positive it works with the larger snapshots.
All right, cool. Homework for the viewer. All right, good. Anything else you want to show us here?
Nope.
All right, awesome. Great work, Todd. Thanks for walking us through giving us a little intro to this library. This looks really solid. We'll put it out there and get some feedback.
Great.
All right, let me stop the recording.